Hi, I'm Maarten de Groff, AI and software developer at Hammer-IMS. Let's take a look at the software driving our camera systems. We call Connectivity 3.0, made for Edge Vision 4.0 current systems. This inspection software is made to run 24/7. The purpose of the software is to detect, classify and archive defects from the current production batch in real time. If there is a defect on the product, the systems will detect it, mark it and try to classify it. It will calculate the relevant information about the defect, like the position and the dimensions, which can then be exported and logged on the customer's servers. So let's get to it. What does the software look like? This is the main view of the software. It can be customized to the customer's needs with different types of visualizations. The map on the left provides a continuous overview of all detections along the material as it moves through the machine. The detections are ordered in the same direction as the material flow. The newest detections appear at the top, while all the detections move downward as the material progresses. Each detection is noted as a letter with a color. The letter represents the type of defect, while the color represents the severity of the defect. The blue lines on the side showing material edges that the system detected. This allows you to see how the material is positioned inside of the machine. On the right side of the screen, you can see the images of the most recent detections. These contain some basic information about the detection, but when we tap on it, you get a zoomed-in view of the detection with some extra information like the width or the height. Optionally, we can show you both the map of the current batch and the map from the previous batch, so you can still review what defects you had during that batch. There are two possible setups, either a rule-based setup or an AI setup. Both share a similar layout. The rule-based system works by first identifying a possible defect using transparent mathematical rules. The parameters that are used are the dimensions, things the width, the height, if it's rectangular or not, and the contrast value. This value is the difference of the intensity of the detection versus the material around it, and can be used to differentiate darker versus lighter spots, for example. It will then be categorized into the type. A rule-based system provides a quick time to market, as no AI systems need to be trained. My colleague Dan will now dive deeper into the AI-based system.
The AI-based systems work by training one or multiple AI models based on the images that were captured during the earlier part of the project. The system then uses the AI system to find defects in all the images of the material. Depending on which system is used, it can either highlight anomalies or it can classify the defect with the correct type. The system assigns a certain level to each detection. The customer can set a minimum level of certainty needed for the software to recognize it as a detection. When we're in the commissioning phase of an AI system, the operators have the option to manually classify detections by clicking on a defect and then selecting the correct letter which corresponds to the correct type of defect. The operator can also delete defects if there were false detections. The classifications will then be used to train an AI system that does the classification automatically. Using recipes, you can change the camera properties which might be needed for different groups of products. On the Cameras tab, you can see the raw view for the cameras. In this view, you can verify the camera properties you selected in the recipes are providing good results. The detection information can be sent to an SQL server, while the images themselves can be transferred to an SFTP server. So the customer gets full access to the data and they are free to use them to generate reports, store them for future use. If there are too many defects within a certain type of material in a running direction, the system can optionally give an alarm to notify the operator. This alarm can either be shown as a virtual stack light on the screen or as a physical stack light. There is also a view to show statistics of the detections, where you can see how many detections occurred for each type of defect in the current batch. Want to see the software running on your own materials? Head over to hammer-IMS.com to learn more about Edge Vision systems.